Yeah, Bob,
I,
that's why I like working with like really smart engineers like Daniel. And the other day I was
You're winding him up now.
I just want to burn Elias because he doesn't want to say I'm ever smart. So face.
Welcome to the Decode Podcast with Elias Malfovan, Daniel Stanfill, and Sean Kincaid.
Welcome to the Decode. We are here with our esteemed guest, Bob Willis. He hails from the UK. He is semi-retired, but still a living legend. Everybody knows that. He created one of the largest collections of interactive training material in the industry. So you will find that on his YouTube at Mr. Bob Willis. You can find his Defect of the Month videos there. You can also find him showing off jellyfish and other schools of fish and cool deer spotting videos, which I know my kids get a kick out of. So, Bob, we could keep going with a lot more of your other accolades with the SMTA and IPC and everything else, but we'll get into all of that. First off, just thank you very much for joining us.
It's a pleasure. It's a pleasure. Looking forward to it.
It's nice to see your actual face. In my mind, when I see Bob Willis, I see the caricature that's on your LinkedIn profile.
Yeah.
So
It's a real person, actually, it turns out.
Yeah.
Well, the funny story is that a couple of engineers who used to work with me at Apex and other shows always used to remember me for my dancing Bob Willis. There used to be a GIF file on my first slide, so anybody that came into the workshop saw me dancing. So Ray Prasad and some, a number of other people were amused by that. Anyway, moving on.
You could go ahead and start with your question, Elias.
So I understand that one of the various defects that you've illustrated so well over the years and in your work, and I love how you kind of show the uglier side of SMT, right? Everybody shows these buttoned up assemblies that have been executed perfectly, but not many people want to talk about when things go wrong. So I think one of the defects that I've seen very commonly through your content and your work are tombstones. And I know you've talked a lot about kind of the usual suspects or the typical causes of tombstones. But I'm wondering about some of the more obscure causes when your investigations have led you away from the kind of usual suspects and to something unexpected and out of the ordinary causing the tombstone defect.
Well, I think that if you are able to look at a process defect happening, and I've said it many times, a picture's worth 1,000 words, a video's worth 1,000,000 words. So if you can actually capture whatever's going on, if you've got a high-speed camera to look at pick-and-place defects or insert or automatic insertion, we used to use high-speed on our automatic axial and radial inserters. And I can remember trying to convince my boss to allow me to spend, I don't know, it's 500, 600 pounds to borrow one for the day. And, within 10 minutes, we didn't need it anymore. We could, now I see. So I've always been an exponent about trying to use video. Now I can create defects, and I've got many defect videos which I've created. I've made them happen. I know how they happen. And that's not necessarily how they happen in the real world. But sometimes you have to be able to create material to put a point across to illustrate something to younger engineers. And then that makes them think, oh, I could try that. And it's just like, it's just another educational tool. But going back to your specific question, of course, you can have design rules, can be an issue. But you can have variations of a good design. And too often people have a great design, and then they have 26 PCB manufacturers supply them with boards. Now, there's going to be variation. It is inevitable. It may be within specification, your own specification, IPC or whatever, but those subtle differences can have an impact. So, solder mask back in the day where we had very thick solder masks, and even today where people decide to put on a double layer of a solder mask because they've got very thick copper traces on the surface of the board. Those subtle things can make a good design be a bad design, or a marginal design be a bad design. So that's sort of one thing. If you use, too much solder paste, and it's generally a case that I'm not a lover necessarily of double height stencils, so I try and use single height stencils wherever possible. So even with pin in paste, I try wherever I can, but that's not always possible, and it's not a cost. It's not a cost.
Is that a
thing.
step stencil?
Yes,
multi-level stencil.
Okay.
Yeah. It's not a cost thing. It's just I've just always been that way. A very good friend of mine set up a stencil manufacturing facility in the UK, and it was so successful that a well-known solder paste manufacturer who then got into stencils bought him out. So he retired very wealthy. But, I worked with him a lot because I could go and play, learning about and trying different things. So the volume of solder paste can have an effect. So all of these sort of critical aspects we've got to look at in detail to try and find the root cause. Solderability of components, subtle solderability of resistors, capacitors can cause one end to reflow and wet beautifully and the other end to be slightly slower. And hence you get this subtle lifting. You've used the term tombstoning, but you've got drawbridging, Manhattan skylining, you've got sort of a myriad of names for it. I've often said that, if you've got a poor design, you can run it in air and get nothing lift, and then you run it in vapor phase or nitrogen and get components lifting. And everybody's blind. Well, it's all about the speed. It's the movement. If you generate movement in a component, you're not in control of the process. So what you want is that very, very subtle movement. Solder paste goes into reflow. The two surfaces wet, the board and the component termination, and we get a perfect joint. So we could go on, and there are probably loads and loads more reasons that I could highlight, but those are just a couple of the common reasons why we see it.
Well, one of the enemies of assembly seems to be silkscreen markings, and there's a common practice I've seen of putting a line in between the two pads to differentiate orientation, to help people figure out what pads belong together, things like that. But that line of silkscreen under the bottom of the component, that can contribute to tombstoning also, couldn't it?
Yeah, absolutely. I mean, I'm not a fan of having legend on boards. So if you're going to eliminate legend on boards, and you've got to think about it, we've got an automated factory nowadays. Quite often, most factories have inspection staff with reference boards, or they have reference images on a PC screen in front of them. You have drawings, you have photographs. Why do you need little marks on a board? But the interesting thing is that if I've got a board with silk screen on, if I go to the PCB manufacturer and say, well, I don't want that anymore, how much cheaper is the board? Oh, it's not going to be any cheaper. However, if you start off the other way around and put it on, you'll find that it is more expensive. So, that's a ludicrous situation. But I often say, get a quote for both and just see what the difference is. But also go into your design CAD systems and see what you've got set up. Some older CAD systems may still have a big box and have D1 as a fault, as a code for a diode, and then they have 26 diodes with D1, D2, D3, D4, D5 along the board. Why D1 and D6? And it's quite logical that it's probably number 2, number 3 you've missed out. So try and minimize it wherever possible, and try and utilize variations, not just what's in the standard textbook, what to use, or in the design system, to minimize that possibility. Yeah, so I totally agree. Ban legend at birth.
Yeah.
It's interesting because I would say that aversion to silkscreen is a reoccurring theme amongst all the people that we talk to who are in the know, right? The Chris Shays of the world, the Bob Willises of the world, et cetera, et cetera. Yet everyone, or almost everyone, is continuing to use it. It just won't go away. We continue to see it on the majority
90% of our
assemblies that
boards
we
still
touch.
have it, even though I have that opinion. It doesn't influence our assemblies much.
Well, I think that one of the things I've learned, from my, when I was a boy, because I used to make boards, we had our own PCB fabrication facility, sort of low end 4-layer boards, flexibles, flexi-rigids, and all that sort of stuff. And, I learned from a very early time that to get engineers together. So I've visited many companies over the years and seen design rules and design books and phenomenal packages, beautifully designed, and nobody reads them. So I always wanted to get my fabricator guys down in assembly and my assembly guys in fabrication just to play. I mean, I always tried to convince my bosses to say, give them a week in there, let them work each other's positions, not, don't let them loose actually pushing buttons, but just be there and experience it. And also bring the designers in so they understand. And I mean, if I think about classic things, the very first time we got into wire wrapping, as an example, we brought the designers on the shop floor. This is what we do. This is what we need. This is how it works. And they all go away, oh, good, I could use it on this, I could use it on that, but they'd seen it. So rather than tell them what to do through a booklet they never, ever read, showing them the new toys, the new things you've got, that sort of, and then they ask more questions, well, how can I do that? What size do I need? All that sort of, the right things to ask. So I think always do the simple things as much as possible.
So, Bob, I grew up doing PCB fab first 15 years of my life. My grandpa started a PCB fab shop in 72, and then my dad took it over, and then that's all I ever wanted to do. So I've been plating tanks since I was 5 years old. I think I found a way, or at least thought of a way, to have our cake and eat it too. When when I got into assembly, I didn't know what a 1206 was. I didn't care. I was PCB fab. Where do you want your holes and where do you want your squares? You know what I'm saying? That's it. And you send me the file and I make it look like that at the end, right? And I thought, what if we reverse image the silkscreen, right, onto the mask? So then you have your negative there, right? And then when you're exposing your solder mask layer, it would basically have that silkscreen wouldn't be applied. Then you would take your silkscreen or legend layer, and you could use white mask if you wanted to, if you were worried that legend was maybe a little bit thinner or for whatever reason, and then expose your silkscreen. But then you would have substrate mask, right? And then you would have substrate silkscreen, and they would both be, in theory, evenly flush with
even
each
plane.
What's your thought on that?
Well, it's something that I haven't seen, but equally what you can do, and we used to do, is just leave an aperture in the solder mask. So you have solder mask, there's a hole in it which says R2. Now, unfortunately, if you're using green, because we've got green PCBs, it's not as obvious. The other thing we used to do is, put the legend into the copper. So obviously there are some design restraints with doing that for high frequency stuff I don't understand. I know how to build stuff. I don't necessarily know how it works. But, all these little different ways of doing things, only a very small proportion of companies you ever see do it. But there are, like you said, different ways of doing it. And you just got to think, well, Well, I think that the problem sometimes is how do we sell the idea? How do you get people wanting to try it? Because if you talk to purchasing, they're not interested. That's what I want. There's your Gerber data. Get ahead and do it. So I think sometimes you've got to sell to the right people. And if I go back many years, one of the things that some solder mask manufacturers used to do is sell to the PCB supplier. Well, they shouldn't be. They should be selling to the design engineer. And as soon as the design engineer thinks, "Oh, this is a good idea," as long as it's not going to impact my cost, then it then comes to the PCB manufacturer as well. So you're converting the right people. You get that communication going, but sometimes it is difficult to get new concepts across. And some of the simplest concepts are the best concepts.
I used to hate when the customer would leave the copper as the reference designators, because they would always do the thinnest, like right, and then it was a nightmare in etching. And I remember I had these 3-ounce boards, right, so they got to go real slow through the etcher, and then they made it like like 6 mils thick, basically like traces as their they wanted me to put like the UL logo and all that. And then sometimes the etcher heats up and my chiller couldn't keep up with it, right? So I'm just kind of screwed, and it would just wipe those things right off the map, and then all that time and material is just gone. And I ended up, like, one time I called the customer. I was like, look, I understand why you're not using Legend, because you don't want to pay for it, but I will pay for it on this one. Just please stop putting it in the copper.
It would be much cheaper in that situation. But it's that communication. I mean, if you were to talk to the right people, but sometimes it's just difficult getting past the purchasing guys. For some reason they think that they have to control everything. Well, they shouldn't.
Yeah.
They should find the supplier, find the right price, discuss it, and then let the technical people talk to each other, say, well, this will work, this won't work. I mean, another classic example, if I may, I worked for a well-known mobile phone company back in the day, and there were only 2 back in the day. And we used to bring the 3 suppliers, PCB suppliers, into regular meetings once every 6 months and say, look, you've all got 30% or 25% of the business here. We've got this particular problem. What we'd like to do is work with you on it. And it was bow and twist, sort of a classic. So, we got the 3 guys together and we said, look, how do you make the boards? You can't leave the room until you tell us that, we want to. And there was subtle differences on press time, press pressure, and all that sort of good stuff. But there was only subtle differences. So then we honed it down, and we were able to get those 3 guys making exactly the same boards, and we were getting the right quality out. And after reflow, the amount of bow and twist was negligible. So that was an achievement. And we said right at the very start, you're not going to lose any business. You're still going to have the same sort of business. You may get a little bit more, 5% here, 5% there. But basically, you're working to help us, and we are working to continue to help you. But that very rarely ever happens.
Speaking of getting the right people to listen, I was reading your LinkedIn profile, and it said you were one of the first people to start lead-free. I have 2 questions on this. Like, how difficult was that back then? And then the follow-up question is, given like how beautiful lead looks, do you wish you never did that?
Well, let me sort of start, first of all, answer the second question first. I've never advocated using lead-free solder. It's some bureaucrats that decided that this was a good thing to do. And there has really been no proof that this has been a benefit. No proof that this has been a benefit. It's cost an absolute fortune for most people. It's obviously allowed consultants to make a lot of money out of it. So I'm not advocating it, but I'm an engineer. You've got a problem. Let's find a solution. So if we go back to the first question about lead-free, I just wanted to learn. It's just like low temperature solders. You know, when they became sort of the super flavor of the day in the last sort of 3-5 years, they were already a conversation piece probably 10 years ago for certain products. So I wanted to learn, and I've always advocated that engineers need playtime. Now, unfortunately, they quite often don't get playtime because the machine's not available. They ain't got time. There's no money available. But I've got to learn myself. I cannot talk about something I haven't done myself. And I think that's the best way of learning. Now, with lead-free solders, we went through, some fun times. I mean, I used to run all the wave soldering training courses for Electrovert, and I've run them for other sort of material manufacturers as well. And we sort of stumbled over a lot of the, copper corrosion or copper erosion, the same as the solder level guys had with their boards in solder leveling. So we learned about that in the early days. We did quite a lot of work with tin copper, which I was quite a fan of. Yes, you've got a higher temperature than you've got with the tin silver copper, but I was quite a fan because they're significantly cheaper. Other disadvantages, you really got to sort of try and implement nitrogen soldering for wave soldering and selective. In the early days, you really needed that to minimize the dross generation or reduce dross generation. But with reflow soldering, you could do it effectively without nitrogen. Today, the majority, I would say the majority of medium-sized, large-scale manufacturers and the high-end, high-technology companies always, insist on using nitrogen. But it is a benefit in certain respects, but it's a cost adder in your process. So you've got to sort of balance that out. In terms of rework and repair, I didn't really feel it as a major issue with lead-free solders, but it was different, and you had to learn how to handle it. I think the other videos I created that was quite amusing to people is where you've got lead contamination in joints. You've got a lead-free joint you're creating, and if you've actually introduced some lead into it by virtue of contamination from the PCB or whatever, how they reflow at a different temperature. So you get what I refer to as secondary reflow. And I thought that was always amusing when we created these videos to illustrate that point. Joints falling apart because you were slightly close to that, that barrier of changing in temperature. So that was sort of fun. I mean, I got a job. We were sitting in the Department of Trade and Industry in the UK, and with a lot of my friends from MPL and various other groups, and this guy who was the leader of the sort of lead-free working party. He says, "What we need is some training material." So myself and somebody else said, "We're going to create the lead-free cookbook." And this was this interactive CD-ROM, which DTI supported. We created this thing, and we had sort of like 20 different videos of different engineers from around the world giving their comments about lead-free, positive, negative, all that sort of thing. And my dear old friend, Dieter Bergman, originally of IPC, but he passed away. I said to him, what I want you to do is just a little bit, talk about lead-free. And it wants to be, sort of 2 minutes, 3 minutes. And it went on for 40 minutes. But it was so classic, Dieter Bergman. It was a joy to listen to. I couldn't use it. I had to edit it. But I just those little nuances just sort of stick in your mind. I mean, on the top of whatever the hotel was near to where Apex used to run, Phil Zaro complaining that he had to sit up there in the baking sunshine without anything over his head. Those little whinges are great. Bless him.
I want to bring it back to tombstoning for a moment, or drawbridging, or Manhattaning, or any of the other terms you used. I'm curious as to your perspective on the optimal aperture stencil design for mitigating tombstoning?
That's a very difficult question to answer, really. I mean, all I can say to you is that if you've got pad size and you've got a stencil aperture, if you want to minimize movement of reflow, you've got to reduce the size of the aperture, but also reposition possibly. So it's actually acting only on the termination. A lot of people have too much solder paste underneath the part to start off with, and that gives you two problems. It maximizes movement, but it also creates solder beads. And obviously solder beads is an issue that many people face. So, I would say that it's trying to minimize the amount, trying to minimize the aperture wherever possible. But you've got to bear in mind where the design was to start off with. You're not going to change the design of the PCB very quickly, but, as a stencil supplier or manufacturer, you can change that, obviously, with permission, which is, again, that annoys me sometimes that you can't do that. I haven't, you're changing my design files. I'm trying to help you guys. I see more stencils than you ever see in your life come through my PC. So if I can give you some guidance, then that's good. Yeah, I mean, that would be my general comment without going into numbers.
Sometimes it feels as though stencil manufacturers are the first to receive the blame and the last to be listened to.
Well, I mean, again, there's a stencil manufacturer that I used to use, which is sort of down the road from me. I used to go in there and, play. And they were, extremely frustrated with two customers. And I offered to spend some time with the two customers. I said, invite them down for coffee or a beer or whatever to their site. And we just sat down and had a chat and, talked about, fabrication, assembly faults. And kind of, I suppose I was the softening side of it. I wasn't the supplier. I wasn't the bad guy. And that worked. And the next time they came back to the stencil manufacturer, they wanted to do intrusive reflow. And I said, well, has the stencil manufacturer asked you for a couple of the connectors? Why would he want that? Well, he wants to look at the thing that he's trying to design a stencil for you. How many suppliers do you have? How many vendors do you have? Oh, we have 4 different vendors for this connector. Are they slightly different color, different plastic, different shape? Oh, yeah, they've got different standoffs on the bottom. So I know you've heard this conversation many times, but it to me, if somebody asks you for something which is going to help, not necessarily solve a problem, help you make the best prototype and then the best production run, it's got to be an advantage. But for some reason, people are always wary about telling the supplier everything. Why? Help them.
Yeah, help us help you, right? And I think I've been encouraged recently by, Daniel as an example, and there's a few other names I could throw out there. Oh yeah, Sean.
Can I get some credit anytime? Unbelievable.
So, I'm glad you picked up on that. But the folks who are really, really willing to go in it at it together. So let's get beyond what the paste file shows. Let's look at the BOM. Let's look at the component mix. Let's look at the component data sheets, particularly when there is a challenge. I can think of a case that just happened yesterday with an LGA that was providing some difficulties. It was having opens as it was X-rayed. And as we looked at the stencil design and then also the component data sheet, we noticed that there was a match between the coplanarity spec or the flatness spec of the LGA and the stencil thickness. So we were using a 0.1 millimeter stencil, and the component data sheet showed that the component had a flatness spec of plus or minus 0.1 millimeter. So it can happen, or it could happen, that the component was warped in a way that it was just at or even above the height of the solder paste. So
yeah, you may be at
9 to form a good joint.
you may be at 90% solder volume, like transfer on the screen print and have a good transfer of pace and a nice shaped brick and still have the component sitting above it when it's flat on the board, supposedly, right?
Yeah.
So with what size was this QFN or LGA is
LGA.
LGA, yeah. So how are you comfortable in? I'll try to go millimeters. So it was
no, go thousandths of an inch or
okay.
American mils.
Look how excited he got. Okay, all right, I can do that.
It's easier for me. So the individual stencil apertures were like 20 thousandths, and the pitch was 39, like 1 millimeter pitch. So
how long is the device? How long is the device?
How long is
I'm
the
thinking,
device?
why have we got this degree of unflatness?
Yeah,
on such a
so the
little package.
device was only about 1.5 inches. So it wasn't huge.
Ceramic, all ceramic,
Not ceramic.
or plastic. Is plastic or fiberglass? Okay.
Yeah. And it had a nice big RF
it's like
shield on top of it as well.
It's like a little FR4 carrier itself with components on it and a shield on top of it, right? Generally,
right. Okay. Yeah. Because I used to
Sure,
when I started doing QFN work, back in the day, I used to make my own out of fiberglass, very thin fiberglass, because it was cheaper. I could have hundreds of these produced by my friendly PCB manufacturer, cut them up and just do trials. And obviously, the fiberglass is more prone to variations in height, potentially. I'm not saying it is, but it's more prone than a ceramic part or a plastic part. So, I mean, I can understand potentially why there might have been a problem. Okay.
And then you take the solder spheres away from that bottom terminated package, and you have even more fun. At least with the balls there, you had some level of ability for the package to kind of still make a good connection.
True, but I mean, the interesting thing is that a lot of sort of engineers, and it comes down to age. If you're old, you know some stuff. If you're young, you perhaps don't know as much stuff. The sort of discussion on LinkedIn about reflow of BGAs. Oh, you can't use flux. Well, I've never used flux, and so I put this little video up there showing every conceivable version of what you could do. You can use flux gel, you could use flux, you can use low temperature solder, you can use no flux at all and use a hydrogen, a gaseous environment. So there's loads of different ways of building stuff. But it was just interesting that a lot of younger engineers, I've never seen that. Well, it's pretty standard practice. Particularly if you go to a contract manufacturer, because they're quite often dealing with lots of different variations in process. But if you're just in your own factory, you've never seen it done, then it might be strange to you.
Yeah, Bob, that's why I like working with like really smart engineers like Daniel. And the other day, I was
You're winding him up now.
I just want to burn Elias because he doesn't want to say I'm ever smart. So face. But it's just weird because I didn't even know my pick and place until probably about 2 years ago. It literally has an option where you can buy where it picks up the component and then dips it in an extra flux tray, right? And then we were dissecting an Apple Watch on an X-ray, and I was like, "How are these guys pasting this?" And they're saying they're not, right? They're just dipping it in flux and then using the
who said they weren't? Who's
probably Daniel?
Who said they weren't, Sean?
Probably Daniel.
Okay. Yeah, it's interesting because what's old is new. We've seen an increase in stencils explicitly for printing flux and some of these modern bottom terminated packages that have their own bulk solder, and it works quite well. It's fast, and you don't have to be concerned as much with your printing,
or as a secondary process or whatever.
It could be part of a dual print process in most cases, right? So there's flux applied, and then one of Bob's favorite multi-level stencils is used to provide clearance for the flux that was printed, and then you print your sort of more traditional solder paste apertures in a secondary process. But printing flux is a lot more forgiving than printing solder paste, right? So
Well, it just depends if you want. It's just messy to clean up afterwards. I think cleaning up solder paste off a stencil is easier than cleaning flux off a stencil, personally. But I understand what you're saying. But I mean, the dipping process, most machine manufacturers do have that capability now. And it was brought. It originally started obviously with flip chip technology, just standard flip chip technology, but also for package on package technology. That became popular. I always preferred using solder paste and dipping into solder paste, so dipping into the very fine grain solder paste, as opposed to using the gel, because I found that more forgiving of warpage. But again, it's you try the different techniques and you find, okay, for that particular size package or that particular size board, you go for one process over another. But as long as you've got some sort of practical experience with each of them, you just, it's just like in fabrication. You use certain materials for certain applications. Certain pre-preg builds for certain applications. Because through using your machines, your process, what will work and give you the best tolerances.
Yeah, it's I like what you said a few moments ago about engineers needing to have time to play. We have sort of a mentor that's spoke to us about similar in a similar fashion. He uses slightly different words. He says, "You're also paid to think." So, getting away from do to experimenting and thinking and playing is something that I think is undervalued. And I get it. There's time constraints, and you've got to get product down the line. But sometimes the results of those play sessions can significantly benefit your operation as a whole.
Absolutely. I mean, we used to have training sessions. I mean, well, I was a process control engineer working in fabrication, and then went into assembly. And I realized that we really needed some more training for shop floor staff. And on a Friday, they would always have sort of half an hour to sort of clean down, get ready for the weekend shift or whatever. And I said, let's have some training sessions. What would you like to learn? Has to be related to work. So I started doing this. My boss gave me a bollocking. That's not your job. I said, but I'm working in quality. This is going to improve quality. And then he had a word with the manufacturing engineer manager, and he says, "Oh no," he said, everybody loves it, And it wasn't wasting time. It was good. That's how I originally got into training. That's how I originally started off with those bits of acetate you put over one of those funny projector things that shine on the wall, and you put your hands over it, make funny shapes. The very first video I ever made, well, no, it wasn't the first, it was probably the 6th or 7th, was my outgassing video. Black and white. I only had a black and white camera. So how to test PCBs for outgassing. And you can tell if it's a thin plating, you've got voids in the through-hole plating. And
just the substrate itself before any assembly?
Yes, just the substrate itself. And it's non-destructive. And all you're doing is putting some high-temperature oil in the hole. You're using a soldering iron to a trace to that hole and see if you get bubbles. And I made it years and years ago. And only the other week, somebody said, "Can I have a copy of that?" He said, "I'd like to do that test." But it was a specification actually introduced by an Italian telecoms manufacturer, and he wanted to actually give this to the PCB fraternity and say, that one bubble is acceptable, 3 or 4 bubbles are not acceptable. Come on, that's unrealistic, particularly where your PCB specifications allow you to have voids in the plating, up to a certain level, of course, depending on the standard. So potentially you will always get, not always, but voids from gassing. And if you can prove it's that, then why are you rejecting the boards? Because you bought boards to level 1 or level 2. So there's a disagreement between specifications there. So sort that out so there is no confusion in the future. But you can use exactly the same methodology when you've got an assembly. If you've got assembly with intrusive reflow and you get a lot of voiding, don't blame the paste. Check the plating on the board as well. Auto insertion, if you're auto inserting your connectors or whatever it might be, is that the thing that's causing? That's very rare for it to happen, but I have had auto insertion actually damage the plating. Only scrape, but I could see after I took it apart and did the microsection, all that sort of good stuff. You could actually see the auto insertion was actually damaging, taking some of the plating off. The guys are blaming the PCB fabricator because I've shown them it must be the PCB because I've shown them with the oil test. And I say, no, hold on a minute, just go back through the process and reevaluate what you're looking at. I'm being a diplomat here.
Yeah, well, it's a good point. Not everything that neighs and walks around on four legs is a horse. Sometimes it's a zebra.
No, absolutely. True.
Your position on videos and using that as a training aid, I agree with that. I think I like and enjoy watching content that folks make of their process. Sean is really good at doing that. He captures, images of inside his assembly machine and inside his screen printer. That's really cool. Is there a technology now that allows for video footage to be captured inside a reflow oven?
Yes, there is.
It looks like some of your posts have already done it almost.
Well, some of my videos are obviously, I wouldn't say trick. They are trick in so much that they're not in a reflow oven.
Yeah,
hot air.
So some, yeah. I mean, I use IR. I've used a vapor phase type process. But yes, you can buy. I'm desperately trying to remember which well-known supplier of profilers offers it. But I interviewed them at Productronica. I was doing interviews last Productronica, wandering around and having fun. It was great, paid to talk to people about technology. But there was one supplier. So if you do a search for reflow camera or something along those lines, you'll find it. It's not the big ones. It's not the well-known brands, but it is a brand that you'll be able to find. The video, I have to say, the video quality it was okay. It wasn't as good as I would have liked it to be able to sell the point. So if I was trying to convince you it's your stencils that are causing the problem, I kind of would find it difficult based on the video information. But you can get a video camera, you can stick at the end of the reflow oven, and as long as you've got good depth of field focus capability, you can see components falling off. That's a nice thing to show. So there's certain things you could do. You can look at degree of warpage, movement, and try and reference one height above the other. The very subtle things, you perhaps have to find another technique to be able to illustrate it.
I wish they made our reflow ovens out of glass, so we could watch it.
Yeah, it'd be cool.
Like I seen a vapor phase one time and they had glass. You could actually see it happen.
Yeah. There's 2 or 3 manufacturers have glass, but it puts the price up dramatically. There was a time when Electrovert in the UK used to sell a competitive reflow oven called the Whirlwind, and it actually had glass ports at the side, and it was wonderful for showing, movement and things. But I can't talk about it any more than that. But it was great. So I understand what you're saying, but certainly there's 2 or 3 vapor phase manufacturers have that capability or do offer it, but it'll put the price up. And the nice thing about fabrication as well is lots of fabricators have windows in their machines, and you can stick a video camera, and as long as they perhaps turn down the pressure, you might actually see something happening. Otherwise, it's just up.
I was thinking about wrapping my camera in Kapton because I got a small one, it's an inch.
Yeah, but the problem is that it's the temperature rise on your unit, even though it's protected by a high temperature tape, isn't going to stop reflow of the part inside that tape.
It won't have enough insulation to prevent it from
I'm gonna sell
reaching
that
temperature
that
itself.
reflow pretty soon. I might just try it, see what happens. It's like a $200 camera. We'll see what happens. Just see.
It's
tell you
worth
what,
it for
why don't you
science.
Why don't you just send me $200 right now, and I'll tell
What's
you that it failed, and we'll call
what's
it good.
what's beautiful is it records off the camera, so like I can actually keep all the footage even if it dies. So we'll have.
Well, I've still got one of my old cameras I used to use for wave soldering because I like to video warpage of boards, components lifting as they hit the wave, solder balling was always a classic I like to capture. And you can actually see the tip of the camera housing here has all deformed. And that's only in close proximity to 250 or 60 degrees C. So it's probably about 3 inches away. But over time, that softening effect. So
I didn't know
give it a go. 200 quid. What's 200 quid?
That's right.
At the end of the day, when I die, you know, my kid, I'm sure he'll be okay with it. But I didn't know. Because I was looking at buying a wave recently, and I didn't know that it actually goes up like this on the conveyor. And then because you got to
because you have to have
it's a little bit more like that.
Contact
not like
point.
that. It's
like
that's
7
the
degrees.
USA
not
version.
quite
We go
20.
hard. The UK is yeah. But
well, the Japanese always used to pretty much flat.
Yeah.
Because obviously all the boards they used to produce were single-sided boards. So as you increase the angle, you've got better drainage. So when all the wave solder machine manufacturers are trying to sell to the Japanese market, they're always getting poor results. All single-sided boards had incomplete fillets because the solder would run around the pad. It would be on the lead. It would still be soldered and perfectly reliable, but you'd always have an open joint. But if you took your Soltec, your Electrovert, your Ursa, and dropped the angle on single-sided boards, you didn't get the same degree of drainage, and consequently, you got 100% joint.
Wow.
So,
because then I was like, all right, the machine's not that bad, but then now I got to buy this special conveyor to catch it afterwards. It's like this giant thing, and then if I want to make it like slope into anything automatic, I got to buy another thing for that. And it was like, and then the magazine I'm like, this is adding up real quick, you know, just all these extra things.
Back in the day, we used to have a wave solder machine, which was a solder cut solder system. So basically, you fully load the board with all the long legs. You pass it through the process. You have a spray fluxer. You have a preheat. It goes through a deep wave. And we're talking about a wave height. You're pumping probably about 1.5 inches depth, as opposed to sort of 6 or 8 millimeters. So it went through there, all soldered, wonderful. Then it goes through a bacon slicer. So you've got 3 rotary blades, chopping it all down. And then it goes into a fluxer, preheat, and then the final solder wave. But because exactly as you describe, if you put a machine and then another machine and then another machine, you start off with an operator sitting at a chair loading the boards. Great, having a wonderful time. And then you've got somebody up the other end taking all the boards off, putting them into a rack, and then we had to have a small little lift which took that down to... But it worked, you know. So it's exactly as you described. So you haven't invented something new. It did exist.
Yeah.
But the solder cut solder systems were amazing, particularly if you were doing very high volume, but you couldn't do wide boards. Our boards were sort of, I guess, about 3 inches wide, because if you go too wide, you get any warpage at all. The old bacon slicer, straight through the fixture, straight through the board. Real mess.
Wow.
And the sparks were quite impressive as well.
So, Bob, you position yourself as semi-retired now. What exactly does that mean? What are your plans moving forward for involvement in the industry? Are you still going to be attending events, still creating content? What are Bob's plans?
Do you still present or speak at any events, or is that...
No. if I'm very honest and candid, you can't make it pay these days. IPC changed what they do. SMT have always been at the same sort of level of support for people, but IPC chopped the number of days you got your accommodation paid for. So they would pay for a flight, they would pay a stipend, and then if you were successful, you got lots and lots of bodies in the courses, so you could make good money. And certainly during the lead-free times, everybody that was on the circuit made good money. So if you got 80 or 100 people in a room, IPC were obviously canning it in, which no disrespect, that's a commercial organisation, but it's difficult to make it pay. And going to a show to the US, I'd love to. I mean, I thoroughly enjoy our business, and I thoroughly enjoy it, but it's just not. It's just not worthwhile nowadays. And I'm not trying to make money. I'm just trying to have a good time, but it's just not worthwhile. But going to Productronica, as I hope to do this year, but I haven't been spoken to yet, to do interviews and things. I wanted to bring back my defect of the month, but actually a clinic, because a few years ago we used to do them at Apex and SMTA, where I drank coffee all day, and any supplier who had customers there that wanted some advice, and whether it be advice that their product was the best thing since sliced bread, or just advice, they could chunt them along to me, and I'd sit, drink coffee, and talk technology. So it was great fun. I thoroughly enjoyed it. I have done a couple of sort of webinars specifically for commercial companies, and off the record, and don't tell anybody, they just pay me in wine.
Beautiful.
Well, it saves invoices and things. I mean, it's a couple of $100, for me doing something. It's not going to really worry the tax man. But that's it's just simple. There's no administration, and it works. But doing failure analysis now, yes, I can look at something and say it could be X, Y, Z, but I don't have the facilities. Well, I've got my microscope still behind me.
Sean, he said Z instead of Z. It was X, Y, Z.
They say that in Canada too. I'm used to it.
I'm missing these interpersonal jokes.
Well, because I'm from right by Detroit, and so we get a lot of Canadian spillover. They say Z, and I tried teaching these.
No, it's uncommon that he's familiar with any type of saying, colloquialism, phrase, turn of anything. Like it usually somebody will say the most common abbreviation or word or anything, and we actually get totally sidetracked kind of like we're doing now, but this one's my fault, I guess.
So yeah, I mean, yes, I still would do and do a little, but I mean, when you do retire, it's fair to say that there's lots of things that you can do. Obviously, you've mentioned my drone stuff, my scuba diving. I just came back from a week in the Red Sea scuba diving, and 4 dives a day, 22 dives in the week.
How's your years? How deep did you go?
Deepest was 30 meters, because I'm not allowed to go to any depth greater than that because of my insurance.
Yeah, 30 is as far down as I go. I'm more of a coral guy, to be honest with you. That's what I like to watch, and see.
Yeah. Well, I mean, like the best experience was the dolphin visit. We had 12 dolphins turn up and rock around. So that was kind of neat.
As long as it's not a killer whale.
Well, Bob, we've got SMTAI next month. I mean, and we've got a booth there. We'll be doing interviews. You don't even have to work. What would it cost us just to have you dancing in our booth the whole time?
You already told you. How many bottles of rosé?
How many bottles of wine?
Yeah, that's right. How many bottles? Because we'll bring them.
Well, you can have the GIF. So you got the GIF. So you can have the with no cost. So that's good.
That
good
is
enough.
Good.
We've got video confirmation.
I guess one more real assembly question I had is, everything's getting smaller and denser and more complex. How do you see that affecting the assembly challenges like tombstoning when you are packing all those discretes into tighter and tighter areas of space and tighter together. Is that more of a requirement at the design level or at the assembly level to make sure it gets put down right?
Well, I think it's both. But if you look at chip components, I can remember doing my first 0201, and then we went to the 01005, and then the whatever the next two sizes down from there. And it
008,
was
004,
and smaller.
006, 003.
But the problem is that if you look at the specifications, I mean, I started off with the 0201 and then 01005, and what we did is we bought parts and measured the differences between the suppliers, and there were variations in the termination.
Sure.
And as you went even smaller, there was a lot of variations between different suppliers, so you could get variations on defects because of those variations. So
Wow.
the other thing is that the poor fabricator, some of his tolerances are bigger than these parts. So
Sure. Yeah.
that's the real world. That's the real world.
Yeah.
And I really struggled when I was doing sort of process trials with the ultra small parts, trying to video them because they're so small. And I referred to them as mosquito poo. Because the things are that small. But in seriousness, I think that we got to a limit quite a long time ago, really, with PCB fab. We are asking these materials, its etching processes, all these things to do things they were never really designed to do. So we are stretching the technology. So we're putting more and more time, effort into getting the best out of these materials. I mean, Sean knows
at a yield that won't kill you, right?
Yeah, but I mean, he knows that to overcome this stretch, this warp, whatever, he has to do something, and it's not necessarily in the textbook. He's already done the trials. He's having to, you got to do this. You got to find a sticking plaster on the wall, and that makes the machine work better.
Daniel, what did I tell you today earlier before my eye appointment? How do you fix warping?
You put it in between a couple cinder blocks and put it in the oven at 350 for an hour, like a casserole.
Yeah, but you forgot about the copper clad.
The FR4 in between. Yeah.
That's an important part. You don't want to scuff up your board.
Details.
But Bob, I'm telling you, we do this all the time, and it flattens your board 100%. It's every time, and it looks terrible. It's a freaking concrete block inside of a big giant Grieve oven, right? It's horrible, but it works, and there's no damages to the board, right? Now your board's flat as can be. It's unconventional, but Bob, I feel like almost like these traces that these guys are wanting on their inner layers, it's almost like they want us to become wire bonders. It's just, what are we doing here? Right? Like, it's like, you want to run this through an etcher? You're like, what? It amazes me.
Yeah, but it's just if you relate etching as a inline process to inline cleaning, when we used to do that, you try and figure out, is this jet blocked? Is this jet blocked? Is this jet blocked? And we had to try and find ways of detecting that with cleaning systems. You have to guarantee the consistency, whereas the cleaning, not so much. It's gonna have an impact at some point, but when we're talking about etching, that's
you know how we did it on the etcher? We would run all the panels in. We'd fully flood the machine with panels, and then we'd stop the conveyor, right, and then turn on the etcher, and then turn it off, and then from there, when your panel comes out, you'll be able to see if there's any etching. Like, it'll be dispersed, right? And then the areas that still have that copper there, nothing was spraying on it. The only thing they got on there was overlap.
Yeah.
Cleaning would be much more difficult, though.
Well, I think the fabrication side is more difficult, but an opinion. Okay.
Well, speaking of opinions, Bob, we couldn't be more grateful to you for your time and sharing them here with us. Like, this is a pleasure for all of us, and I know we've been looking forward to it for a while. So Just want to thank you for doing this. And I know you're semi-retired. Is there anything you want to plug, like your YouTube channel or anything to direct people on how to find you?
No, I mean, I wrote a book last year on robotic soldering, so that's gone. But we raised the money I wanted to for charity for prostate cancer for that. So I've got nothing, really to plug. I mean, all of my books are available. They're free. People can get them if they want them. There's 4 of them. There's all the defect guides I produced. Obviously, all of the posters and slides and some of the webinars are all available from SMTA to download free of charge, member or non-member. I had that in the contract. So,
Well, it's
the
obvious you
material's
pay
there.
it. It's obvious you pay it forward because it takes so much work. All of us who have just done any producing of content of any kind at all know what it takes to do it. And you have really pumped a lot of valuable, informative, educational content out there that I know myself and a lot of other people in our audience likely have enjoyed. So thank you from all of us for your hard work in the area and helping bring us all forward with it. And thanks again to the audience for listening and or watching. Thanks for tuning in our channel. Please like, hit subscribe, all that thing, tell your friends. Thank you, everybody. Until next time.